troubleshooting Gennex inverters. So here we have some common errors or faults that we can be encountering where we are when we use our Gennex inverters. So right from the one that has to do with fan. So let's start from the fault 01. On our inverter, we have code for each of the faults that might arise on maybe when there is any issue on site. So on the first fault that we talk about is the F01, which deals with the fan issue. This might come as warning. It might come as warning. It can be to retrieve the service center. The fan can be lowered by any that two ports from the board, from the main board, or what's doing what's supposed to do is just spinning. Definitely the fan itself is faulty. So the inverter may not send commas. So whichever way we have it, once we can be able to notice what is the cause of the lot of fan, or we can just restart the system and it start working again. So count that one as a warning. So, but if you do all that, we restart, we check the fan, nothing block it, and no physical something that we can say, okay, this is the issue that caused the fan not to roll, or it's spinning, but it's not, it's still showing a 01. So we count that one as fault, which it will require to retrieve to the service center. Then again, we have FO2, which is over temperature. Over temperature can occur when the fan is not working. Over temperature can occur when the fan is not working. If you notice that the inverter is showing over temperature, then we still notice that the fan is spinning at the same time. This thing can also come as fault, but majorly it's a warning. It's a warning code. If we notice the fan is working, but still showing FO2, we do all our best to restart the inverter by turning off the system and turn it on again, and the FO2 still persists. So that one will come as a fault. But in case we just notice that the fan is not spinning, FO2 might set in, because the fan is supposed to be cooling the board when it is working. So if that one happens, the thermostat will sense the heat and it will sense into the inverter that the temperature is getting too high. So if inverter keeps working at that state, it may cause damage to the board, to the main board. It may heat up the coil and burn it. So all those observation, we need to keep it. We need to make sure that our inverter is well ventilated. Anyone wants to install the inverter, it must be ventilated. At times, fan might be rolling, fan might be spilling, and still having over temperature, not because of anything, but because of there is no proper ventilation for inverter. So, and this might cause the damage to the inverter. Then what we have again is FO3, which talks about the battery footage, the high footage from the battery. This usually comes maybe at times we mistakenly connect the high footage inverter, a high footage battery to the inverter. Inverter that's supposed to use 24 volts, we mistakenly connect 48 volt on it, maybe out of ignorance or we don't oversight. So the inverter will show FO3. So if inverter show FO3, we know we'll confirm that our battery is okay, which is the 24 volt is for 24 volts, and the inverter is 48 volts, battery is 48 volts, and we're still having the FO3 that will come as a fault. So the main board is sensing high. So in that way, it will not sense it. It will not be a warning again. It will be that will have is just like the reverse case of FO3. Maybe we have FO3, we have FO4, which means the battery voltage is too low. So we may want to connect 48 volts and connect 24 volts to the inverter, or the battery voltage is low already. In the Gennex inverter, we have a cutoff voltage that will program for our system, which makes you to maintain your battery very well so that you don't overuse the battery. So we have cutoff voltage for all our inverter. So once the cutoff voltage setting, the inverter will show FO4. And when it reach a lowest voltage that will set for the inverter will go off permanently until you charge it to get to the point of come up. The inverter sense it as appropriate voltage for it to operate on. So once you notice the FO4 on the Gennex inverter, which means it is battery voltage is too low. So in that case, we need to check our battery. At times, if battery voltage is low and the cutoff voltage that we set is high, maybe we'll set it to about 44 or 48 or 46 rather. And the inverter is, you are reading your battery is sensing about 40, 42. The inverter will not recognize it as a voltage that we use to come up, because what you set on the program 28 is what inverter will act on. If you set it at program 28 to be 44 and your voltage of the battery is about 43, the inverter will not recognize it as a appropriate voltage to operate on until you get to that voltage, which is 44 that you set. So on this, it will help you to manage your battery so that you don't overuse the battery and the battery is not just going flat before the inverter goes off. So again, we have the FO5. This is critical issue. which some people used to encounter when on site. The FO5 is when the output load, any appliances connected to the inverter is short circuit. In short circuit means the negative and the neutral and live of the appliances has been breached together. So the inverter will be sensing that short circuit for a few seconds. If that persists or it happens frequently, it may goes to a fault. At times, FO5 will come as a warning. If you notice it in time, you restart, you check what is supposed to be checked. Maybe your load, you turn off all the load, all the breaker that connected to the output, you turn it off. You turn your input that connected to it, because it may come in either way. The output cable might short circuit with the input cable. It is still the short circuit because it will be seeing it as feedback. So it is still the short circuit. So in that way, to troubleshoot it, you have the battery breaker. Firstly, you have the output breaker. That is why it is necessary for any installation to have breaker for easy troubleshooting. You turn off the battery, the output breaker, you turn it off, you turn off the input breaker, then you have your inverter, you turn off the battery. After doing all that, check all what is supposed to be checked, maybe in your appliances, in your input connection, you check everything, then you turn on your battery breaker first. When you turn on the battery breaker first, the inverter, if nothing is connected, if any appliances short-circuited, the inverter will run successfully. If the fault is not from the inverter will work successfully on battery mode. After that, you introduce your output. After you introduce your output, you check all the appliances one by one, whichever one you on and that short circuit come up on inverter, definitely you know that this is where the problem is coming from. Then from there, you separate it, then continue to troubleshoot your inverter. The short circuit might come from simple lamp holder. Maybe we are using a screw bulb. So if that bulb burns, if that particular bulb get burnt, it may short circuit the live and the neutral together, which may feed back to the inverter. So all that observation we need to take. So that is for the FO5. Then after turn on our output load, the breakers, inverter is working well, then we need to on our input breaker as well, so as to confirm that it's not from the input as well. If the input and the output wire is connected, is bridged together, it can still show us the FO5, which is output short circuit or short circuit. So, and we must not allow this to be coming often and often, because at the end of the day, it might damage the main board of the inverter. Then another fault that we have here is FO6. It's FO6, which is output voltage is abnormal. In the output voltage might be abnormal if the input that is going into the inverter is too high. In Gennex inverter, the maximum voltage you can have as input is 240, 250. So if you're having something like 260, 270, the inverter will sense it as abnormal voltage. Meanwhile, it will not send it back to, it will not bypass it to the output for your load, because they design it in order to protect the appliances at the output side. Inverter works like it will, from the input, it will bypass to the output when you are not using, when you are using utility. So it will cut off the voltage on the output side if the input is too high. So on this case, if this thing is continue frequently, it may later resolve to the fault 06, which is output voltage is abnormal. When the inverter is trying to cut it off, then at the end of the day, the inverter get damaged, it will show the F06 as fault. So on the other one, we have F07. So the F07 is overload. Overload can still come as short circuits when the output and the input cable connected. It can still resolve as overload, which is 07. Because if that happens, it will be like we are using the inverter to power itself. So that is what short circuit of output and input looks like on the inverter. Then another thing is overload that we all know. Maybe inverter rated at 3 kilowatts and we are using it to power appliances of about 5 kilowatts. Actually, the inverter can withstand a surge of, if it is 3 kVA, it can withstand the surge of 6 kVA, 6 kilowatts for a particular seconds, maybe for like 5 seconds or 10 seconds before it cut off. But if this persists, it happens frequently, the overload may occur as fault, which means the main board has been affected due to the overload that is coming in every time. So before we can now say this error, this warning has become a fault, has become an error, we need to troubleshoot. So in order to troubleshoot, we turn off the output breaker, then we restart the inverter. We can turn off the output breaker, but to be sure, turn off the input breaker. Then we turn off the battery breaker. Then after some minutes, maybe we give it like 5-10 minutes, then we turn off our inverter again by turn off the battery breaker first. Then if that one works on battery mode, if inverter works on battery mode, definitely the inverter is still in good condition. But if you turn it on and instantly it shows you F07, definitely the inverter has been damaged by the overload. So if it is not damaged, it will work well. The only thing we just need to do is just to reduce our appliances. What we power on it, we check, is there anything connected to what we are not want to connect with the inverter? Maybe a socket is there, the plug, something we did not provide to you, we did not have provision for to use it on inverter. So we can just check through our load and see if there is any additional load on the load we powered with inverter. So another fault that we usually have is F08. F08 is similar to another fault, 51. FO8 is voltage is too high, which means when the voltage is too high, the internal component are damaged. The internal component that damaged is the U16, the components like microchip. That is what is sense the high voltage. So if this thing happens, there is nothing we can do than to restart the inverter. We can restart the inverter. FO8 might disappear if you restart the inverter. It might be sorted. Fear that. But if it is something that has taken too long, maybe the FO8 has been there before we notice it. It has been long before we notice it. It might have turned to component failure, which will affect a section of main board. So if that is the case, we need to retrieve the inverter to the service center for repair. Then FO9, this is a major issue that we used to encounter on our inverter. If there are some causes of this FO9, the main causes of it is inappropriate commissioning of inverter. It can cause it. The surge, either from the grid or from the PV, it can cause the FO9. So if the surge is coming from the PV, which is solar, our solar part, if the surge occur, it can cause the FO9, which is burst soft start fail. The burst soft start fail is a particular section of the DC to DC switching on the inverter. It majorly affects either IGBT on the inverter, on the main board, or the MOSFET on the main board. So this fault is particular to switching when the inverter wants to start up. When the inverter wants to start up and the voltage that is required to start up is not enough or is too high, the inverter will show FO9. Most time it burns so many components. If this particular fault happens, it burns so many components like IGBT, like MOSFET, like resistors and all that. It burns it. Then another thing can still burn is a particular capacitor that is on the main board, which is on the DC to DC converter side. So it burns all those components. So if this thing happens, it really disappears when you restart the inverter. It really disappears because before the FO9 can occur on the system, definitely something critical has gone wrong on the site, either the surge or over voltage or short circuit. All those can still cause it. So if we are to protect all this, to protect FO9 is a complex stuff, but the recommendation we give always work on protection of FO9 On the input, we introduce the appropriate breaker on it. If you use appropriate breaker for the PV, for the input, the grid, and for the output, it helps a lot in curbing the fault 09. And again, we recommend surge. We recommend surge for the AC side and the DC side, which is solar section. If you are using solar, we always advise to use DC surge that is appropriate rating. Then we also introduce the power limiter. This power limiter, we use it. Some people don't know how to set it. They will just get it and install it. The power limiter has a setting, has some settings that will still protect the fault. If you just buy the power limiter, you just install it without any settings, it may not work because you don't know the particular setting on that power limiter. What we need to look out in setting of power limiter is the maximum voltage that it should take. The maximum voltage it should accept from the input, then the maximum charging current it should accept from the input, then the minimum voltage it should accept, the low voltage it should accept from the input. So all this, we need to set it on the power limiter in order to protect our inverter. This also goes to the fault 51, which is overcurrent or surge. So the overcurrent or surge is also the same issue that occur. This same fault happens on the same section that FO9 occurs majorly. Because if surge can come from the solar. Maybe we have inrush current, that is surge, or we have overcurrent. Overcurrent can come, maybe we're in our design, we didn't give allowance of the charging current. Then when there is surge, the inverter cannot handle it for long, and this affected the inverter. At times, fault 51, which is overcurrent or surge, may disappear after restarting the inverter. It may disappear after restarting the inverter. Either we restart it according to what I've been saying, turn off the input breaker, turn off the solar input, turn off the output breaker. Then after that, you turn off the battery breaker. Whenever we want to do the troubleshooting, we want to restart the inverter, we should know that the battery must not go first. The battery must go last. So you turn off the solar first, the input breaker, which is grid, then the output. Then after that, you turn off the battery breaker. So when you want to restart it again, you start from the battery. When you want to restart the inverter, you start from the battery. You turn on the battery breaker first. After that, when you notice our inverter is working, if the inverter is working on battery mode, which it means that the inverter is still okay. It means that inverter is still okay until you introduce another parameter to it, maybe introduce grid and they start showing, you know that the fault is coming from that particular aspect you introduced earlier. But this F51 is common on the solar side of the inverter. This is because either when we design is above the specification or there is component failure on that aspect. But the F51 is majorly common to the solar section of the inverter. So in order to protect the F51 from happening to our inverter is getting an appropriate breaker. Whenever we want to size a breaker for solar, we should know that we are using DC, and the voltage of the breaker we want to get must not that higher than the voltage that is coming from the maximum voltage that will come from the PV. Then the amps as well. The breaker has voltage and as well as current, the amps that it can withstand. So we should check before we use any breaker. The same thing as DC surge. If you want to protect something of 250 volts and you went ahead and used 600 volts DC surge, you know that you are not protecting anything, because the 250 you are trying to protect, you are using 600 volts to protect 250 volts. The maximum you use in that regard is either you use 270, which means, or if you can get the 240 volts or 260 volts or exact 250 volts, which will make the breaker the surge to work accordingly, so that the surge can arrest any inrush current that is coming. So after we restart the inverter is okay, then we need to check the solar aspect of our work so that we can know that, okay, this is where the issue is coming from. So, but if we turn on the battery breaker and the inverter starts showing the fault, it means that the inverter needs to be repaired and retrieved to the service center. So another case we do have is okay. Another fault we do have is F58. F58 and F08, they are just like a reverse case. F58, F08, and F06, they are just like reverse case. F58 means that the output voltage is too low. The same section that affected on that F58, on that F08 and F06 is the same section that gets affected as well. So what we can do is just to get our inputs, footage correctly. Input footage like grid or utility input footage, we need to get it correctly, then the output. So majorly the input always affect the output. If the inverter is working alone, most time it faults. Like when you introduce grid to it, or whenever I want to do this, to protect this particular fault. The voltage protector is as the same as a power limiter. The voltage protector is just like a power limiter, but we set the voltage protector in order to reject any inappropriate incoming input, so that it will protect our inverter from having this fault. Then the F60 is, this majorly happens. This fault majorly happens when we connect two or more inverters together. It can happen to any inverter that connected in parallel or stacked together, which is majorly our inverter. That's what we does. So this fault is power feedback. It will come as warning. It will only come as warning until you get it right. This happens when you connect when you're trying to loop all the inputs and outputs of the two or more inverters together. At times, the cases may be reverse of live to neutral. When we have terminated the neutral from one inverter, it should go to neutral of the second inverter, to the third inverter, and so on. Then again, from life of first inverter to second inverter and third inverter, and so on. So maybe in the process of now connecting the line and neutral together, we mistakenly put live where neutral is supposed to be. You will be experiencing these faults every time you are trying to connect it. The inverter will be telling you that there is power feedback on what you are doing, because you have reversed the polarity. You have reversed the polarity of the inverter. So before this can become an error, definitely it has take a longer time before you now know. And if this thing happens, it will really damage the part of parallel card section. Majorly, it will damage the control card. That is, if you don't notice it in time. But to prevent this, there is a way we can do it. Either we loop we use something we call voltage sequence. Voltage sequence is another device that you can use to check if your phase are sequence or not. If the phase are sequence, it will show you that this voltage is sequence. It will show each voltage from each phase. But if it is not sequence, it will still indicate where the error is coming from. So this device will help when we are doing either three-phase installation, or we are parallel more than 2 or 3 inverters together. Then there are some other faults that is not here. which is majorly based on parallel. It's majorly based on parallel, and sometimes some people don't really get it. So like F50, F72 is when you have output current, when your output current is different. So you will be experience the F72 fault. So in this case, what you need to check for is the current sharing cable. If the current sharing cable are not well tightened, or one is losing, or one has removed, and you have connected all the input and output together, it will be showing you the F72, which means the output current of the inverters are different. So in that case, it's not an error, it's not a fault until you make it a fault. Maybe you didn't get it in time, and that has resulted to a fault. So what this normally affects in inverter is control card and some spares on the parallel section. Then another fault that we have is F83. Is F83. In this case, we have when we want to connect Gennex inverter in parallel, we advise that all the power banks should be connected as all the batteries should be connected as one bank, and each inverter take their source from that particular bank. So if you are using 8 batteries, you don't connect 4 for one, connect 4 for another one, and parallel the inverter. The inverter will be sensing different voltage. The inverters will be sensing different voltage, which is not good for the inverter that is in parallel. So if you want to do that, you connect the inverters together, then you connect all your battery bank together, so that all the inverters will be having same voltage from the battery. The same thing we do when we want to do for solar, only if it is high voltage inverters. It's not advisable you connect all the solar and start taking source from the solar, either you use bus bar or you use breaker. It's not advisable for high voltage inverter, but you can do that for the low voltage version of our inverter. So another fault we can encounter, and it's not a fault, it comes usually as warning until we get it right. It will be coming as warning, which is AC input. This is F84. It's F84, which is AC input voltage and frequency are detected differently. This may come up. Maybe we use different input to power the inverters. Some phases are not stable. We use it to power one inverter. We use another phase to power another inverter, and they are on single phase. We use different phase to power them. The frequency may not be stable. The voltage may not be stable. So if you are encountering something like that on site, we know that we need to use same source of grid input to power all the inverter that is on single phase that will parallel together. So another one that we need to check is F86. The F86 usually comes like maybe we set one inverter to be 230, another one to be 220, on the output. So this will be AC output mode setting is different. So in that case, we need to check the program 28, then which is maybe we'll connect it in a parallel. Then we want to use split method. We want to use 1 inverter per phase or 3 inverter per phase, and we want to achieve 3 phase. So we need to check program 28, then program 9, so that we can set our output very well. Then another one we need to check is commonly we do have some questions about F61. Some people set the inverters on program 5. When we are using this one is common when we are using lithium battery. Some people will try to connect the BMS to the inverter by selecting, maybe in our program 5, you select lithium battery, or you select Pylon Tech feature, or you select Weco. All these are designed for a particular brand. It's not for all the lithium battery. In this case, if you're having this kind of fault, it is advisable you use user-defined in your program 5, in order to avoid all the F60 or F61 that will come up on the inverter. So that will be all for now. If there is any question, let's ask. Thank you.
Thank you very much for that, Abbas. That was very insightful. So we'll be taking 1 or 2 questions from our installers and dealers. So in as much as we'll not be able to attend to all questions, verbal questions, you can actually type in your question to the chat, and then we'll take it up from there. Questions, please, from anyone. Engineer Abbas, we have a question for you right there. Please, what is code 10 stand for, and what is the solution? Hello, Abbas, can you hear me?
Okay. Thank you for the question. The code 10, error fault code 10 means the output voltage is the rating. This common when firstly, when the voltage coming in is too low. When the coming input voltage is too low, it will not transfer it to the output. So it will be showing the output voltage is the rating, which is it won't accept the voltage that is coming from the grid. It's only when this thing can be resolved when you have the inputs either from solar or from the grid. You can turn the breaker off once your inverter is connected to the battery and battery is at normal voltage. It will power very well. But if the voltage coming in from the input is too low, it will be showing output power rating, which is F10. Thank you.
Okay, thank you very much for that. I hope we're able to answer your question, Sadaramola. So we have another question here from Abuna Matthew, and he says, please, how can we do such calculation?
Okay, on such calculation, like I've mentioned this before. So to calculate the surge calculation, we have different type of surge. We are not talking about brand. We are talking about the rating, the size of the surge. We have the one of if you want to select for surge, DC surge or AC surge, there is a way we check. We will know the symbol of the each maybe either it is DC surge or for AC surge. Then the ratings we want to check is the voltage and the current the surge can handle. Like I said earlier, if we are trying to protect voltage of 250 volts, we should get a surge that has something like that that has something like that ratings. Then the current as well, we should get if you want to protect something of 80 amps, we should not go and get surge that rates at 120 amps. It will not protect what we need. We should get something that handle 80 amps or a bit higher, because normally inverter can still handle something of ×2 of the actual power of the inverter. But if you get something like 80 amps to protect 80 amps, it's okay. If you get something of surge of 270 volts to protect something of 250 volts or 260 volts, it's still okay. So in order to protect that, in order to know that, we check the the footage, the ratings on the surge that we are buying. Hope the question is answered, sir. Thank you.
All right, thank you very much. Okay, so we have the third question from Mr. Steve. And it says, what's the appropriate breaker for input and output breaker size for the 5 kVA 48 volt system with 4 batteries and with 8 batteries?
Okay, thank you for the question. The appropriate breaker for the input and output breaker for 5 kVA 48 volt system for 4 batteries and 8 batteries. The appropriate breaker for the 5 kVA, we recommend 63 amps breaker for input. For input voltage, we recommend 63 amps breaker. Then for the output breaker, we all know that the battery is a backup for the load. So if you are powering something of more than 1 amps on each battery, something of 1 amps, the battery breaker we recommend for 4 batteries is about, if you can get 4 amps, 5 amps. So if you cannot get 5 amps, we get 6 amps maximum for the battery, for the 4 batteries system, in order to regulate the load and to protect the battery as well from being overused. So we can get 6 amps breaker for the 4 batteries system, and we can get 10 amps or 16 amps, which is a bit high for the 8 batteries, but 10 amps breaker is okay because of the amps we are getting from the each battery. We recommend to use 1 amps out of each of the battery. So in order to protect our batteries from being overused, we can use 10 amps breaker for 8 battery system, and 6 amps if you cannot get lesser, 6 amps maximum for 4 batteries system. Thank you.
Okay, thank you very much. Okay, please, Mark, we appreciate if you can help us unmute Mr. Olusegun Wola. He has a question for us. Mr. Ewola or Mr. Ezeibo Chibuke Justin. We both have a question for us.
Okay, please, I'm trying to unmute you guys. Please, I'm asking you to unmute. So just accept the unmute so that you can start speaking.
Yeah. Good morning. Good afternoon.
Good afternoon. Can you hear you?
Yeah. Owola Olusegun. My question is, I want to know the difference between floating and charging current, floating and bulk voltage, and how they apply on the system.
Hello, sorry, we're not able to hear the better part of your question. Can you just quickly rephrase, please?
Yes, I said I want to know the difference between the cutoff voltage, bulk voltage, and floating voltage, and how can it be set on the inverter?
Okay, thank you for the question, sir. The cutoff voltage, bulk voltage, and the float voltage. These voltage are used to set the charging status of the battery. The bulk voltage is what you need when your battery is very low, which may be high when you are charging it. So the bulk voltage may be around 57 volts for 48 volts system. This will allow the battery to charge faster. Then the float voltage is when your battery has been fully charged, where it will rest. That even if the grid or the PV voltage, the PV input is still available, it will still be on that particular level. So that is when the float set in. The float always lower than the bulk voltage. And the cutoff voltage is when your battery, what you set for your inverter to cut off when the battery is reach a particular level. Each battery has different type. If you on the program 5, if you choose if you choose user defined, you can be able to set all these parameters from program 27, 28, and 29, which is float voltage, bulk voltage, and the cutoff voltage. If you choose the user defined on program 5. But if you choose a particular type of battery on program 5, the settings is there already. You cannot tamper with it. If either you choose flooded battery type, or you choose AGM battery type, or you choose lithium battery type, either Weco, Pylontech, or other type of battery on program 5, it's a preset on its own, so you can't tamper it. But if you choose user defined, you can be able to set all those parameters on the program 27, 28, and 20, 26, 27, and 29. Thank you.
Okay, thank you very much for that. Okay, can we have Mr. Izelo, please? Please help us unmute Mr. Izelo.
I've asked Mr. Zelo to unmute, but I think he's not unmuting. We have questions on the chat.
Okay. All right. So in response to the appropriate breaker size. The Mr. C further asked the question, please, the 4 amps to 6 amps breaker, is this a DC breaker or an AC breaker? Because I asked about the output breaker size of the inverter.
Okay, thank you for the question. When we are talking about grid input and the output on the inverter, we are talking about the AC voltage, not DC. So if you want to protect AC voltage, you get a breaker of AC breaker for the AC voltage. If you are talking about solar voltage, you get DC, or we are talking about battery, you get DC breaker for each, for them. Thank you.
All right, thank you very much for that. Do we still have any other questions? Okay, so I think this will be the last question we'll be taking for today. From Sadeboye, on the 5 kVA 48 volt system, please, how do you arrive at 6 hands and 10 hands breaker respectively? Thanks.
Okay, I've mentioned it. On each of the battery, we advise to take 1 amps load on it. And if you have 1 amps, that is about, for each battery, if you are using 1 battery, the maximum current you can pull out of it is about 1 amp. And if you do our calculation well, the 1 amps, you will be getting something of 220, 230 watts out of the battery at that time. So if you have like 4 batteries like that, you'll be having roughly with 6 amps, you'll be having like 6 you will be having something like 1.3 kilowatts of load to power with that 6 amps. So pulling out 1.3 kilowatts out of the battery at that time, so it's appropriate to use 6 amps if we are to go by 220 watts per battery. So that is how we get to the size of the breaker we are using for the output to protect the battery. Hope that's clear, sir.
All right, thank you very much for that, Herbert. And I would say we have come to the end of today's webinar. We hope you enjoyed this session as we enjoyed putting this together for you. And if you're not able to meet up with the beginning of the webinar, you can kindly check our YouTube channel in order to watch this clip again. And then we also advise you to subscribe to our channels, our YouTube channel, or other social media channels for daily updates and other updates on when the next webinar will be coming up to be shared on those platforms. As always, we are ready to assist our clients in any way possible. We truly appreciate serving you. I cannot wait to see where we go together next. Thank you for your time and enjoy the rest of the day. Thank you.